Hey everybody, this is your 5-4 Math Excel video on how you do your problems. So to start with, on 541, which is your number 1, write an equation of a parabola with vertex at the origin and the given focus, which is 11, 0. So since the line connecting the focus and the origin is horizontal, then it has to open either left or right, and focus is always in the inside, and so it has to be on the right, since it goes through 0, 0, so the sketch of it would look like that. Now, there are many formulas in this section, and it gets more and more complicated when the vertex is not 0, 0. So to start with, we're just going to treat the origin as one of the points, like it says. So your first formula is when it's a horizontal parabola, the form should be x equal 1 over 4c y squared, and that will have focus c comma 0. And so the main thing is your distance is the c, which is 11. And so you do 1 over 4 times 11 y squared, and so you get x equal 1 over 44 y squared. The next one is the focus is given as 0, negative 9, and it again has the vertex at the origin. So I would just draw a little sketch of it. It's below here. Your distance is 9. But what you do is you take your equation for the vertical parabola. Let's compare that to the horizontal one. The horizontal one says x equal y squared, and the vertical one says y equal x squared. So yes, there are things in front of it, but just in general, remember that if it's y equal x squared, then it's going to be vertical. Again, you're using 1 over 4c for a, so you think of it as y equal ax squared, and a is really 1 over 4c. So you're doing 1 over 4 times negative 9, so that's negative 136 x squared. Now, based on this sign, it just confirms that when it's down, you have to have a negative. The next one says find the vertex, the focus, and the directrix, and then draw it. So there's lots of things to this. It is x equal 12 y squared, which is given, and so it's an x equal, and so that means it's horizontal, and because the 12 is positive, it's going to be to the right. So I usually do a little quick description. Now also, just to help you remember it, if it's y equal x squared, it'd be vertical and up. If it's y equal negative x squared, it would be vertical and down. So yes, you're going to have coefficients sometimes, but that would just tell you, like, is it up or down? And then if it's the opposite, like if it's x equal y squared, it would be right. And if it's x equal negative y squared, it would be left. So just think about how all those things relate to each other. So here's your formula, and this is the first time today in the Math Excel video that they're using HK for the vertex instead of just 0, 0, as they tell you, like the general form. So the general form is y minus k squared equal 4p times x minus h. Now, if you're at the origin, then hk is really 0, 0. And so it's just y squared equal 4p times x. So this is when it has the h and k, though, because sometimes you're going to have a vertex other than at the origin. Okay, so let's get back to our problem. So we had x equal 12y squared. Now what we're trying to do is we need to reverse it and then solve for y squared. So we have to bring this underneath. So that's 1 over 12 times x. Now when it's in this form with the y squared, then you have a formula again. 4p would be equal to that. So 4p is equal to 1/12. And so now divide by 4, so you're basically doing 12 times 4 in the denominator, and then that would give you 1/48. Okay, so a really small number. The next thing is the focus, when you have horizontal ones, would be at p comma 0. And so you just take that number, 1/48 comma 0. Then the directrix would be, in this case, the vertical line that's the same distance apart. And so x would be equal to negative 1/48. So basically, when you're doing your graph for this, the focus would be on the inside and the directrix would be a dashed line the same distance apart. So that's how you do it. Now there is a little bit of a hint that you can do, and I have it highlighted. You can do graphs of these equations sometimes using the calculator in a way that you're not used to. So this is where you really want to learn the calculator if at all possible. It says menu, graph entry, equation templates. Okay, the equation templates is the part that's new to you. And then you're going to choose parabola, and then there's going to be the vertex form, which is what we want in our case. It says x equal a times y minus k squared plus h. So let me show you how to get to that. First, we start a new document, add a graph, and go to graph entry edit. Now this is where number 3 says equation templates. And before you saw a line with having slope intercept, vertical, or a standard form. So if I hit escape to back out of that, parabola would be what you want here because it's based on x squared or y squared. So your vertex form would be with the parentheses. You have your a times x minus h squared plus k, where hk is your vertex. Now the standard form is when it's like all multiplied out, where sometimes in some of the problems you're going to do FOIL first and then expand your terms, and so you're going to solve for y that way and not have parentheses. Now the next vertex form has x equal instead of y equal, and so you have your a times y minus k squared plus h. Then your last one was x equal ay squared plus by plus c. And they have your little picture of it. So in your case, it says x equal 12y squared. So go through your choice until it's x equal, and then it just says y squared, so you go to the bottom one. So it already has the y squared and the y for you. It changed it to E1 for equation 1. It just says 12y squared, so you say 12 here, and then press tab, then put 0y and 0. So when you do that, it graphs it for you. Now, you can't do the Control T for the table because it's not a function. Also, if you tried menu and then table, it's disabled. The reason is because, there's more than one y value to the x values. But that is what it looks like. Now, here's the other thing that's going to be really useful for you, and I know I get to it in a little bit. If you press menu and then analyze graph, like this is where you usually do your 0, which is x-intercepts, and your minimums and your maximums. And for calculus these days, they're using dy dx. But for your class, what there is a good thing is analyze conics. Conics are parabolas, ellipses. There's different ones that you'll get to later. And so for analyze conics, if you press 8, this is where you're going to have lots of things. I mean, it even has things for a center of a circle. But the main things you're going to be looking for are the vertices and the directrix. We'll get to that in a few minutes. Now, this shows foci because it's like more than one focus. Now, foci, since it's plural, really is like covering for if it's an ellipse or a hyperbola. But you can even do it for the parabola. Now, I know I'm throwing out different shapes at you, but basically an ellipse, an ellipse would be like a stretched out circle like that, or like that. A hyperbola would be kind of different. It does things like that, and there has lines like that. And then you know what a circle is. So some of these options you're not going to use right now, just foci and directrix. So if you do foci, that's number 3. Now, it doesn't look like it's doing anything, but it's just waiting on you. And so if you just remember, a focus has to be in the inside of the parabola. You just use your mouse pointer and see what happens if you go inside. Okay, there it says equation 1. And then if you're just inside, you can click it. And it shows me this. It's 1 over 48. I'd like to move this value. Okay, I had to escape, and now I'm going to hit this to move it. And that tells me my focus is at 1 over 48, comma 0. So that was exactly what we got when we did it by hand and getting 148, comma 0. And then the directrix would just be the opposite sign, and it's x equal because it's vertical. So again, if you do menu, analyze, and then analyze conics, the directrix is number 5. And again, if you just move this around a little bit, okay, right there, it did the line. It's really close to the y-axis, so it's not really helpful that much yet. But if you hit escape and then move it over, you can see that it tells you x equal negative 148, which is the exact same thing as we got right over here. So those are the main calculator features. And then since you can't really use the table, you might have to just look at whatever you can. Like this is a 1, and that's how wide it is, so to speak. It's like 1 above and 1 below. It's a multiple choice graph, and so you're going to have to think about which one it is. And you can always do a table by hand, like plugging in different x and y values to see if it should be wide or whether it should be narrow. Okay, the next one, this has x equal 1 over 44 y squared. So there's no extra numbers, and so your vertex is still at 0, 0. We know if it's x equal, it would be horizontal. And your formula is basically with the 1 over 4c. So if you want to think of the ones as canceling or just cover them up, then you say 4c equal 44. Or you could have even said 1 over 4c equal 1 over 44. That's a little more weird. But if you just set your denominators equal because both say 1, then you can say 4c equal 44, so c is 11. And because it's positive, then our focus is at positive 11, 0, not negative 11, because that would open left. So this is horizontal and it opens to the right. So again, if it's positive 11 for your focus, then it's going to be negative 11 for your directrix. The next one says write an equation of the parabola with a vertex at the origin and the given directrix x equal negative 6. So this time they're giving you a directrix instead of a focus. You just work it out. So it is horizontal. It's going to open right because your focus is going to be, and I have this down here, but since the focus would be positive 6, 0, because the focus and directrix are always opposite signs. So in this case, we have a focus at 6, 0, which means C is 6. So now your easy formula for this is just x equal ay squared when you don't deal with h's and k's because you're at the origin. So this would be like x equal 1 over 4c times y squared. So a is the same thing as the 1 over 4c. So you do 1 over 4 times 6, which is 1/24. And that gives you x equal 1/24 y squared. So then your next part is the same instructions. This time you have a directrix that's y equal 4.3. So this other one was x equal, and that was horizontal. This one's vertical. So remember, they could be either based on if it's x or y, and so forth. So if you know your vertex is 0, 0 from the problem, and you know your directrix is y equal 4.3, your focus would be the opposite. So instead of positive, it's negative. The other thing, and this is really important, if it's vertical, then your focus is going to be 0, something. And, whoops, I did not mean to put left. It's vertical, and this has to open down. Vertical and opens down. And so that would be like this. And here's your focus, and here's your directrix. So your formula is y equal 1 over 4c x squared. And since your focus number was negative, then you put the negative here. 4 times negative 4.3 gives you this, basically negative 5 over 86 x squared. So this would be a parabola that opens down. Make sure you keep it in fraction form. On the next one, it says a cross-section of a light reflector is a parabola. The bulb is located at the focus 3/4 inches from the vertex. So this is where you can actually see that parabolas do have to do with everyday life. Maybe you have Dish Network or DirecTV. You know, those dishes are modeled by parabolas. So even if it's not used, somebody had to make one with the right dimensions and arcs, so to speak. In this case, it's a light reflector, and so it's going to be like that, and the focus is in the inside. So your vertical parabola is at 0, 0. Your equation is y equal 1 over 4c x squared. And since c was 3/4, because you got 3/4 inches, then it's going to be 4 times 3/4. Your 4's cancel, so you get 1/3 x squared. So that's your equation. Also, your focus would be 0, c, because it's on the y-axis, and your directrix would be down here, parallel to the x-axis. So then the next part says determine the advantage of this parabolic design. So in this case, the light will reflect off the parabolic reflector, so the light is parallel to the axis of symmetry. Light from the bulb will be focused in a straight line from the end of the reflector, making it a better tool. Okay, on the next one, it says identify your vertex, focus, and directrix, then sketch the graph, and you're given y equal x squared plus 6x plus 2. So a couple of quick things. We know A is 1, B is 6, and C is 2, because those are the coefficients and the constant. So based on that, we know it's vertical and opens up. So when you're doing this by hand, you would have to be completing the square. So if this type question was on the SAT or ACT on the section where you cannot use the calculator, you would have to do it this way. So the first thing is you look at your middle term and you're going to divide it by 2. So 6 over 2 is 3. Then you're going to have to square that, so it's 3 squared, which is 9. And then to complete the square, that means you're going to have to add it here and then subtract it here, because you can't just randomly add something without subtracting the same thing. The reason why we're doing the complete the square is because we have to change from this form to the vertex form, where it uses parentheses. So that's the whole point. So we go from x squared plus 6x plus 9 into x plus 3 squared. Because remember, the square root of 9 is 3, and 3x plus another 3x gives you 6x. And then this part is 2 minus 9, which is negative 7. All right. The other thing is, if you have a plus, but the formula requires a minus, you need to think of this as minus a negative. So this is y equal x minus a negative 3, all of that squared, minus 7. What that tells you is if you use your negative 3 here and your negative 7, that's your vertex. So now, with your a term being 1, because the coefficient, then you'd have 1 over 4c equal to 1. And so then c is just simply 1/4. So basically bring that over, and that's the same thing as 0.25. So again, in your case, it's a positive x squared, it's vertical, it's opening up. The focus has to be inside this thing. I'm going to put negative 3, negative 7, like around there. So your focus has to be above and your directrix has to be below, and it's horizontal. Okay, so that means if it's up, it's 0.25 up. So you take your negative 7 and go up 0.25, and that gives you negative 6.75, which you would then go to convert to a fraction and get negative 27/4. Okay, how you do that, just real quick, go to the home screen, go to calculate, negative 6.75, menu, number, there is approximate to fraction. So you just do that, and that gives you your negative 27/4. Okay, and then the directrix would be the opposite. Instead of adding 0.25, you have to go down a little bit, down that much. So you get negative 7.25, and then convert that, and it's negative 29/4. And so then you can see how these are related. This was 27, this was 29, 28 would be in the middle. 28/4 is negative, or if you do your signs, negative 28/4 would have been negative 7. So from there, you would then have to graph it. Okay, so that's how you do it all by hand. Now, here's the steps on if you use the calculator. So the calculator form of this would be 1x squared plus 6x plus 2. So you type that in. And like I showed you a little bit earlier, you can do menu, analyze graph, analyze conics. So 3 was foci, which is plural of focus. But there's only one focus on parabolas. And then 5 was directrix. So I'll show you how to do this again. If we go to a new document, add graph, then you go to graph entry and equation templates. By the way, it would really help you if you practice while I'm typing this. Instead of line, you want parabola, and it's y equal, so it's going to be one of the top two, and it's the one without the parentheses, and so it's standard. That's how you pick which one, and that's when you put in your 1 if there's nothing in front, tab 6, tab 2. So it looks like that. Okay, and I'll go ahead and do zoom fit, which is menu 4A. Menu 4 for window, A for zoom fit. So that looks like that. Okay, so now to analyze it, we go to analyze graph, which was 6, and we do analyze conics, which is 8. And that's where I want to choose foci. So all I do is I just move my mouse pointer until something shows up. And there it is. Click. And that dropped it. And now I need to press escape and I want to move it. Remember, when the hand is open, you can push in the middle to move it and then drop it. So here's where you got your -3, -27 and it does match what we did over here. Then the other one, menu, analyze, analyze. This time we want directrix, which is 5, and so we just move our mouse over a little bit. Click, there's that line, and again press escape and then move it. And there is your y equal -29, which is exactly what we got over here. So this problem in particular would be really good for you to practice on. I'm sure you're going to see it again. And then you would just have to graph it. Okay, on the next one, you've got y equal x squared plus 8x plus 16. Same thing, you're doing your vertex, focus, directrix, and graph. And you can use the calculator or do it by hand. The next one shows write an equation of a parabola with a given vertex and focus. The vertex in my case was 4, 5, and the focus was 4, 6. So if they're only 1 unit apart, that means C is 1. Now, based on plotting those 2 points, 4, 5 would be there, 4, 6 would be there, and so I know based on that, since F is inside, then it has to open up, not down, and not right. Okay, so this is also like your first example, I think, where there's a vertex not at the origin. Not really your first, but one of your first ones. So you'd have y minus k equal 1 over 4c times x minus h squared. So that's how you would normally think of it, but if you use the calculator or just in Math Excel, you have to move this k term over. So make it plus k. So you have y equal 1 over 4c x minus h squared plus k. So it's basically just solve for y. The next part is you just set your 1 over 4c, like you plug in c as 1 for that. And so you have 1 over 4 times 1, so that's 1/4. Now, because you already know your vertex from this part, it's easy. You just put your y equal 1/4 from what we just did, then change your sign of your x value, because if it's x minus, that means move right. And then this is positive 5, which means go up 5, and so that's positive 5. Okay, on your next one, it says identify the vertex, focus, directrix, and graph. This one you're just going to do like an earlier one also. And on number 12, it says use the information in the graph to write an equation given your vertex and focus. So in your problem, you're given a vertex is 0, 0, and your focus is 8, 0. Now, based on that, you know that from 0 to 8 is 8, so C is 8. And you also just move back 8 units, and so you can do your directrix based on that information. So your directrix is x equal negative 8. Remember, if it's x equal, that means it's a vertical line. If it's y equal, it's a horizontal line. Okay, so now here's your equations with your h and k. Your vertex is hk, which in this case is just 0, 0. Your focus would be the h coordinate plus c. In your case, you just have 0 plus whatever the number is, comma 0. So this would be 8, 0. You knew that already. Then your directrix, you just move backwards, so it's x equal negative 8. Then you have your formula, x equal 1 over 4c times y minus k squared plus h. So if we know our c is 8 because of that distance, and it's positive in this case for c, then you'd have to just do 1 over 4 times 8. Now the next thing is, I know already that our vertex was at 0, 0, but I'm just showing you. You would put a 0 y value, or k value in this case, and a 0 x value, or h value in this case. So y minus 0 is y, and then this just drops out. So you do 4 times 8 is 32, you got 1 over 32 y squared. And that would be your equation. So that's your whole goal. Create the equation based on the graph. So just looking at it again, remember that if you're given this, you're going to have to use a factor of 4. 8 times 4 is 32, and so that's it, basically. All right, the next one. Now this is one of the longer problems as far as words. But again, it shows you how these are used in everyday life. Broadcasters use a parabolic microphone on football sidelines to pick up field audio for broadcasting purposes. Don't know if you've ever seen that, but they really do have that. A certain one has a reflector dish with a diameter of 18 inches and a depth of 5 inches. If the receiver of the microphone is located at the focus of the reflector dish, how far from the vertex should the receiver be positioned? So that's basically your paragraph. So your steps would first be like draw it on the coordinate plane. If it's an 18-inch diameter, just divide by 2, so that means it's a 9-inch radius. Easiest way to do this is to just have your coordinates and then go 9 to the right, 9 to the left. And then it says there's a depth of 5 inches, and so 5 up for both of them. So you have this point at 9.5 and this at negative 9.5. Now this 0.5 is not the focus, that's just how high this thing is, because it says the depth is 5. But your focus, which is C, is unknown. It has to be somewhere between 0 and 5. Not including those numbers, because it'd have to be at least something, and it can't be the exact same as the depth. So then your next step would be write your formula y equal 1 over 4c times x squared. Again, if you know it's vertical, then your focus would be at 0, c. Now the step on this is substitute 9,5 or negative 9,5, which in this case would be harder to use because it's negative. Use the positive because it's easier. So what we do is we put 5 for y, we keep it as 1 over 4c, and then we put 9 for x. Now whether you did a positive 9 squared or a negative 9 squared, you would still get 81. But remember, where the parentheses is matters. Negative 9 squared is 81, which is correct. But if you just type it as negative 9 squared like that, that's negative 81, which is wrong. So that's why it's just easier to use positive. Then we just have to solve for c, so we have to multiply by 4c for this to cancel. And then that means 4c has to be on this side. And then 4 times 5 is 20, so then we got to bring the 20 back over here, divide by 20. So you get 81 over 20. So you do want a fraction answer. You probably need to see whether it wants 81 over 20 or if it wants 4 and 1/20th. Probably this one, but I'm not positive. It says the receivers should be 4 and 1/20th inches from the base of the dish along its axis of symmetry. So since you knew it had to be smaller than 5, that's kind of reasonable, 4 and 1/20th. And so this is where you would probably put 81 over 20th. Always pay attention to whether it wants a decimal or fraction. The next part says graph y plus 3 squared equal 4 times x minus 5. This is where you could use your characteristics to choose the graph, or you could use your equation template. So let's look at that real quick. If we go back to our equation template, which seems to be pretty handy, you go to add graph, then graph entry, and then there's your equation template. So there's your parabolas. Now notice all of these say either y equal or x equal. This has y plus 3 squared. So if you are going to use your calculator, you have to do some work first. So you would need to solve for x, not y squared. So the first thing you have to do is expand this, so that'd be y squared plus 6y plus 9. So basically you're doing y plus 3 times y plus 3. Here's your first times first, here's your outside times outside, inside times inside, and last times last. So just use FOIL, or like I said in a different video, just double the 3, so you get 6. So now you have y squared plus 6y plus 9, and then we just already distributed 4 times x is 4x, 4 times negative 5 is negative 20. Now remember, since we're solving for x, we need this 20 to come over here, and if it was a negative 20, that means we have to add 20 to both sides. So this becomes 29. Now you want to divide by 4 to every single thing. And then I just put x in front. So x would be 1/4 y squared plus 6 divided by 4 is 3/2. Remember, reduce your fractions. Both were divisible by 2. And then you have 29/4. So now that you finally have that, then you can choose the right graph. And so it would have been x equal, and it would have looked like the bottom one. So you put 1/4 here, tab, 3/2 here, tab, and then 29 fourths. Enter. And so that's your graph. You're going to have different numbers, you're going to have it at a different width, but that's your graph. And the next one says write an equation with the vertex 1, 3 and the directrix at y equal 3/2. And basically you have 8 choices on the multiple choice. Think about whether your equations should be x equal or y equal, like which one's squared, and basically work it out. Remember, if your directrix is positive, then your focus is negative, and just, guess and check, or work it out. All right, so that's the end for the regular Math Excel video. The other thing, which I didn't really mention yet, is on the honors Math Excel. There's also questions related to domain, range, graphing, maximums, minimums, things to that nature. So it's definitely graphing type questions, but it's stuff you've had before. So it ends up being 20 questions on the honors, and this was 15 on the regular. All right, so that'd be the end of that video. Hope that helps.